Friends, welcome to the 56th lecture on Advanced Steel Design. In this lecture, we are going to learn more about ice loads. Generally, sea surface or sea ice develops in winter. This is essentially due to the cooling of surface seawater. If you look at a simple statistics, sea ice is about 15% of world's ocean. There is another fact which is bothering as a designer to us is the ice thickness and ice coverage on the sea surface increases progressively in winter. Which is basically a fact which all of us know. Further to that, hardness of ice also increases with age. Okay. These are studies interestingly made by Mahoney et al. 2004 which will be helpful for additional reading for you. Friends, during ice formation, needle-like crystals of ice develop first. Let us look into the process of ice formation. Needle-like crystals of ice first develop. They get modified in elastic ice crust from further freezing. Elastic, you can say ice crust on further freezing. Ice deforms more with the brittleness of the ice crust. More the brittleness of the ice crust, more is the deformation of ice. It causes separation of ice into small cylindrical pieces of about 20 meter in diameter. More details of this progress of ice can be seen in one of my publications. (2019). Small diameters of ice are called pancakes These will be of diameter 3 meter. Large diameter of ice are called ice cakes. Pancakes can cause impact forces on offshore structures, the natural period of these impact forces increases with the increase in wave height. Period of this will also increase in the presence of current. Now, ice cakes which of larger diameter further freezes to form a continuous ice sheet. They are also called as ice floe. Ice floes further freeze to form ice fields. They are extended over a large area which will be about 10 square kilometers. Under the presence of an ice floe, structural motion of ice is governed by the wavelength. Ice floes also impact offshore structures. They are governed by the drift of velocity of ice. Continuous action of wind, wave and current transforms this ice sheet into pressure ice fields. Okay? These pressure ice fields have rough surfaces. These ice sheets can also pile up one over the other. Okay, you have an ice sheet of certain thickness. There can be another ice sheet of another thickness, they can get piled over. Okay, this is what we call as piling. They generally pile one over the other in an irregular manner, and that will result in creation of ice pressure ridges. For example, this intersection of this piece with the bottom one is a classical example of ice ridge, and so on. Further, friends, ice sheet remains attached to the shore. Such ice sheets are called shore fast ice. They are usually developed in winter. This sheet will get detached from the shoreline during spring season. From the shoreline. This happens generally during spring season. Once they are detached, they are called pack ice. Pack ice usually has a width of about 10 kilometers. They remain in continuous motion. The velocity of pack ice is similar to the current velocity. Now, let us talk about what are glaciers. Now, glaciers are essentially ice shells which actually originate from land by, this is land, by compaction of snow layers. And freezing of fresh water. Okay, they result in glaciers. Flow of glaciers results in formation of icebergs. The chunk of ice breaks due to buoyancy of seawater. Further friends, icebergs are more governed by the wind speed current velocity and so on. Temperature below and above the water surface, causes non-uniformity in the formation of ice. Where is the non-uniformity occurring? The non-uniformity comes from non-uniformity in the melting of icebergs. Okay. This therefore results in breaking of ice, unless otherwise it is not broken, it will remain as a continuous sheet. It also results in tilting of the icebergs. It can also cause capsizing of icebergs. Now friends, breaking of icebergs is in smaller form, is called as growlers. They are also otherwise called as burgee beds. Therefore, friends, structural design of platforms under ice loads is governed by 1. Sheet of ice, 2. Pack ice, and 3. Icebergs. So, these are the 3 structural form of ice which can cause worries the design of the platform under ice loads. Ice loads acting on offshore structure depends on many factors. Let us see what are they. The first and foremost factor is the structural geometry of the platform. Depends upon the shape of the platform, size of the platform, etc. So, friends, this is also reminding us that design of structures under ice load is a form dominant design procedure. Okay. 2. It also depends on location of the platform. It also depends on sea state at that location. So, both are location factors, isn't it? I will say this is 2A, this is 2B. The third factor that governs ice load calculation is the ice properties itself. For example, thickness of ice, velocity with which ice is moving, crushing strength of ice, and lastly, the ice structure interaction. So, ice load calculation depends on many such factors. Okay. Having said this, let us ask a question: how do ice force develop? What is the analogy behind this development? Friends, please listen. When ice hits the vertical member of an offshore platform, ice failure occurs. This failure is attributed to continuous action of wind, wave and current. Now, this results in horizontal force of the member. This is continuous in nature and hence is a dynamic load. Secondly, it also causes transient vibration to the platform. Why this is developed? This is due to the fact that formation of pressure gradient during development of ice. Let us talk something about ice structure interaction. To understand the ice structure interaction, let us talk about the common failures that occur due to ice loads. 1. Limit stress failure. 2. Limit force failure. Now, failure of ice occurs at the ice interaction surface. When the environmental forces act on the ice, like wave, wind and current, their magnitude increases and the magnitude is very higher than the ice strength, and therefore ice fades. Like waves, wind and current have higher magnitudes than the ice strength, which causes ice failure. Let us see what are the common modes of ice failure. Ice can fail by buckling of ice sheet, two, it can also fail due to crushing of ice sheet. Once the ice sheet fails, ice structure interaction surface causes movement of ice ridges around the structure. Ice ridges will move around the structure to cause an additional impact force on the platform. Interestingly friends, this motion of ice, which is relatively important with respect to the motion of the structure, reduces the force in the structure. So, the advantage is this process reduces the force on the structure. To be very specific, the ice force on the structure. So, let us ask a question: what are the factors that govern ice sheet failure? Okay. Ice sheet failure depends on ice thickness. It also depends on the dimension of the structure to which ice impact is considered. Dimension moment I say is size, shape of the platform. The third one is the strain rate, which is very important. There are other modes of failure. One is they fail by shear, two, radial and circumferential cracking, three, it can also be due to creep, four, the failure can also be due to spalling. Now, interestingly friends, when the ratio of ice thickness to leg diameter of the structure is very less, that is thickness of ice is very more compared to the leg diameter or the member diameter. If this ratio ice thickness by member diameter is very less, and this will induce larger cross section of the member to withstand ice force. So, as a result, the diameter of the member is very large. Encountering ice force is very large. Having said this, ice failure generally takes place by creep at lowest strain rate or by crushing at higher strain rate. So, friends, the ratio of ice thickness to the diameter of the member, if it is increasing, then the failure modes will shift from conventional failure to radial or circumferential failure. Okay. So, the failure modes will get shifted from the conventional modes of failure to formation of radial or circular cracks. Okay. Having said this, one should use carefully the suitable empirical relationship to estimate the ice force on non-force structures. Okay. In the literature, if you look at the ice loads, there is a term called level ice. Level ice actually induces random vibration on the members of the structure. Out of all the scenarios of failure, the most sensitive parameter is crushing ice failure. Crushing ice failure is considered as the worst scenario because crushing ice failure induces maximum ice force on the member. Okay. So, friends, as a summary, in this lecture we started learning more about ice loads. We learnt also about the process of ice formation. We also learnt about the failure modes of ice. We also learnt about the crushing ice failure, which is a very important phenomenon of failure because this induces maximum ice force on the member. Have a thorough reading. I can recommend a textbook on Vinodini 2019, which is talking about analysis and design of offshore compliant triceratops platforms, where the theory about formation of ice and the process of formation and the factors governing the ice load are clearly illustrated in the textbook. Okay. Thank you very much and have a good day.